this Vijnanika Shaktis, after a long time actually, we are assembling because you all had exams. So we thought we will give a break for at least a week so that you can all take part in the Vijnanika Shakti program again in full enthusiasm without having the burden of your examination. So today it's a special day.
Long time
It's a special day because sorry, it's a echoing that was happening. So it's a special day because it's special for from the science, like from the mathematics point of view. So all the mathematicians are today very excited. They're celebrating all over the world what we call as a Pi Day. And we will know from we have two eminent speakers today with us, who one of whom actually is an acclaimed mathematician, Dr. Purobi Mukherjee. And another important event that we are going to celebrate, in the sense that we will learn more about him, who is actually, on quote unquote, we say he is a genius in physics, as genius in physics is none other than Albert Einstein. So today is his 143rd birthday. It's a special event for actually all the physicists also, because all over the world physicists are thinking and taking this opportunity to pay their tribute to Albert Einstein, who has done a great deal of things for the physics, for the mathematics, for the advancement of many different sciences. That we will know from another eminent speaker who we have with us. He has not joined probably yet, but he will join soon. He is Dr. Jajati Nayak. Jajat Kesari Nayak, and he is a scientist, senior scientist in VECC, Variable Cyclotron Facility in the Salt Lake. So that is something that we are going to do after a long time, calling eminent scientists so that you can interact with them. That is what we are kind of trying you to have scientific mind, so that you can interact with the scientist, ask questions. So you are always free to ask questions. So today, before the speakers, because they are having some internet issues, so we should start our program, and we want to now start with the Vijnanika Shakti children participants who have written to me that they want to also show what they know about the day, also want to show what they know about Albert Einstein, their work, and the importance of pi. So in that category, actually, I have got 4 names and who wanted to be very actively participating today. The first participant, Vijnanika Shakti child, is Dimira Mukherjee. She is in class 3, and she wants to talk about Albert Einstein, and from a different aspect. What she wants to say is about something about the value education. So I'm eager to listen to all of you, not only for Albert Einstein, but what do you know about pi and what is the significance of pi, before we go and move on to our eminent honorary guests that we have with us. So Dimira, you want to start?
Okay.
Please go ahead.
Ma'am, can you see the screen?
Yes, we can.
Albert Einstein. Who is Albert Einstein? Albert Einstein was a theoretical physicist, a scientist who uses calculations, math, biology, and chemistry, along with a lot of theories to understand the complicated universe, and was probably the best of them all. He is best known for his equation, E equals mc square, which states that energy and matter are the same thing, just in different forms. Over here, you can see that E stands for energy and M stands for mass. C stands for constant, which means speed of light, because the speed of light is constant. Early life and education. Albert Einstein was born in Ulm, Germany, 14th March 1879. His parents were Hermann Einstein, who was a salesman and engineer, and Pauline Koch. In 1880, the family moved to Munich, where Einstein's father and his uncle Jacob founded Elektrotechnische Fabrik J. Einstein and Kiel, a company that manufactured electric equipment based on direct current. Albert Einstein attended a Catholic elementary school in Munich from the age of 5 for 3 years. At the age of 8, he was transferred to the Luitpold Gymnasium, now known as the Albert Einstein Gymnasium, where he received advanced primary and secondary school education until he left the Germany 7 years later. This is the house that Albert Einstein lived in. This is a picture of them all. This is Luitpold. This is a picture of the students. The origin of his passion. Einstein was excellent at maths and physics from a young age, so he had learned much faster than his classmates. When Einstein was 12, he taught himself algebra and Euclidean geometry over one summer. Einstein also independently discovered his own original proof of the Pythagorean theorem at age 12. Max Talmay, who was a family tutor, said that he had given the 12-year-old Einstein a geometry textbook, and after a short time, Albert Einstein had solved the entire book. From then on, Albert Einstein jumped to a higher mathematics. Soon, Albert Einstein was so good at math that I could no longer follow. His passion for geometry and algebra led the 12-year-old to become convinced that nature could be understood as a mathematical structure. Einstein started teaching himself calculus at age 12. And as a 14-year-old, he said he had mastered integral and differential calculus. Thank you.
Thank you,
Very
Dimira.
nice.
That was good.
Very nice. Thank you.
That was
so
good
much.
information on Albert Einstein, and to let us know that why he is from a young age identified as a genius. One thing is like what is intelligent quotient, like IQ? Any of you know?
Like 160 something, I thought.
So Albert Einstein is one of the very few people who have a very high IQ. And this is a task for you to find out what is IQ and why is it related to the intelligence that we say. It is the amount of actually the gray matter that we have. So now what is gray matter? These are the other things that are a subject of biology, of course, but this is something that a parameter or something that we use to say someone is how much intelligent that person is. And Albert Einstein has a very high IQ, almost double the common person had. So that is the reason why he was termed as genius. And of course, we knew from Dimira's presentation that from a young age, his teachers already told that why he was genius. So after this, we have Divyanshi Dash, and she is in class 6. And Divyanshi said she is going to also she is eager to talk about Albert Einstein.
Yes,
So
ma'am.
Divyanshi,
Yes, ma'am, I'm sharing. Ma'am, can you see?
Yes.
Okay, ma'am. Hello, everyone. I am Divyanshi Das from class 6 and I read in BDM International, Kolkata. Some information on Albert Einstein. Albert Einstein was a German-born theoretical physicist, widely acknowledged to be one of the greatest physicists of all time. Einstein is best known for developing the theory of relativity, but he also made important contributions to the development of the theory of quantum mechanics. Relativity and quantum mechanics are together the two pillars of modern physics. His mass energy equivalence formula E is equal to mc2, which arises from relativity theory, has been dubbed the world's most famous equation. His intellectual achievements and originality resulted in Einstein becoming synonymous with genius. Albert Einstein's brain. One parameter that did not explain Einstein's mental prowess, however, was the size of his brain. At 1,230 grams, it fell at the low end of average for modern humans. Albert Einstein's brain traveled around the United States for 40 years after the scientist's death. Many scientists have attempted to find an anatomical explanation for Einstein's genius, but the link remains unclear. Albert Einstein's brain was removed within 7.5 hours of his death. His apparent regularities or irregularities in the brain have been used to support various ideas about correlations in neuroanatomy with general or mathematical intelligence. Studies have suggested an increased number of glial cells in Einstein's brain. Thomas Harvey removed Albert Einstein's brain. Facts about Albert Einstein. When Albert was a boy, he fell in love with physics when his father gifted him a compass. Albert's theory of relativity helped scientists understand how the universe works. Albert Einstein refreshed his brain by playing the violin. Einstein didn't wear socks because Einstein's big toe regularly pushed a hole into his socks. To him, socks were a pain because they often would get holes in them. Awards won by Albert Einstein. Barnard Medal in 1920, Nobel Prize in Physics 1921, Matsuchi Medal in 1921, Copley Medal 1925, Time Person of the Century 1999, and many more. Some quotes by Albert Einstein. Life is like riding a bicycle. To keep your balance, you must keep moving. Anyone who has never made a mistake has never tried anything new. Thank you.
Thank you, Divyanshi. And
Very nice.
it was
Very
wonderful,
nice.
wonderful to know about Einstein's brain. So that was what we are
Thank you,
talking
ma'am.
about, like why he was called a genius, and it's exactly why people invoke the curiosity among the people, that what made him do the most wonderful theories, calculations in the best possible way, what other physicists only thought to do but never could do. So that is the reason why he is termed genius, and it was seen that he had tremendous number of gray cells, matters actually in his brain, and that's what made him genius. But exactly why it is, like how it is correlated, still not know. And but still we try to understand. But thank you very much, Divyanshi. It was a nice presentation, and you know now that what Albert Einstein said, if you're not doing any mistakes, of course you're not going to learn. So this is for everyone, that of course if you're doing something and if you think you have failed, if you're not studying, if you're not securing very high marks and you're thinking that, well, okay, I have not done very good, but it is not relative to what you are going to become in next 20 years. These things are very little thing. You'll understand when you grow up, that when you grow up, you'll look back, you'll see that, okay, for class 6, when I was a student, I used to just think about the mathematics, what will be the number for my mathematics exam. But this is not everything that will judge you to be what you can become in next few years. So that's a very promising and motivating presentation. Thank you, Divyanshi. And after this,
Thank
we
you,
have
ma'am.
Suhana. Suhana is also in class 6. And Suhana, I'm very happy that Suhana is someone who is becoming active member of Vijnanika Shakti in last few actually classes. And Suhana wrote me like spontaneously whenever I actually posted this about this program that she wants to participate, she wants to present. So this is something what we want from all of you. Be spontaneous, just write to me. If you think something you want to do, we will find out a way so that you can show what you want to do. Okay, so any setting, it's not something like, let's say like for some program you are not thinking that we are not fit for this, it's okay, but be there, be present there, be active, be like more vocal, so that we know that's what we want to do. Okay, so Suhana, you want to share?
Yes, ma'am.
Yes, thank you.
Hello, everyone. Myself, Swana Saha. Today, I will be presenting a PPT on Albert Einstein. Ma'am, should I start presenting?
Yes, Suhana, you should share your presentation and you should start.
Okay, ma'am. Ma'am, can you see?
We cannot really see your screen, but something is getting shared that we know. So you start sharing, share the screen, then select the PowerPoint.
Okay.
Yes, now can you see your screen, but we cannot see your presentation.
If you can't, you can share it to Vijnanika Shakti, to me, or
And then I can project,
yes,
actually.
yes.
Ma'am,
Give it to
now can you
Anuja,
see?
No, we cannot. We can see the screen of the Zoom, but not your presentation. So what you have to do, you do the screen sharing, okay? And then from the screen sharing, then you select the file, the PowerPoint file. Okay, Suhana, one thing you can do, you can share the presentation to me in the Gmail. Is it possible for you?
Actually,
You
she's not.
attach the presentation and then I can open it for you.
Actually, she's not getting the
Ma'am, now can you see?
No, actually
Ma'am,
we
now
cannot
can
see.
you
Yes,
see?
now can
now
see
it
something. Is
it
it your
something.
presentation? Yes, go on.
We can see her. Yes.
Albert
Yes, we
Einstein.
can see.
Okay, ma'am. Thank you, ma'am. Thank you for helping. Let us know about Albert Einstein's childhood. Albert Einstein. Albert was born in Württemberg, Germany, March 14, 1879. Albert played the violin from age 6 to 13. He was a slow talker. He started learning calculus in 1891. His family moved to Milan, but he didn't. His first job was a fashion girl. Some pictures of Albert Einstein. Some information about Albert Einstein. After WW2, Einstein is an ardent advocate of the formation of one world government. He is the signer of the Rules-Einstein Manifesto, which describes the threats of nuclear war. Albert Einstein dies on April 18, 1955. His ashes were scattered in an undisclosed location. Some more information about Albert Einstein. Einstein tried to find a job as a teacher, but in fact could not find any job at all for over 8 months. He found work part-time as a teacher of math and physics. He also became a technical expert third class at, at the Swiss patent office. His son, Hans Albert, was born in 1904. This was all about Albert Einstein.
Finished? Suhana?
Yes, that was finished. Joanna, actually your internet connection is getting...
One thing I wish to tell Anuja, requesting all the children, especially Suhana, this is live performance. All the public, they are watching. So when you present something, read in front of your teacher or in front of your parents, so that you can say very nicely, correctly. Okay. So
Suhana is doing for the first time here, and
yes.
she has not actually is not like, for example, Divyanshi, Dimira, and Yarishita will be presenting. There are many other children who present regularly, all the time. So this is something actually is good, but she is coming forward to do it.
That's
And
true,
that is what we
but
encourage.
you should practice. That is, all the children should
Definitely.
practice in front of teacher.
Yes.
You are doing excellent job, very nice job. But
Yes, and it will improve, I'm
the
sure.
pronunciation.
But keep practicing. Right.
Keep
Keep practicing the pronunciation so that like you become more confident of what you are saying. So, but this will improve definitely, and we want to see you again and again. And thank you for all the information that you have collected. This is something what we also encourage, that you do spend some time apart from your book reading from school on doing something which is related to science, to know about someone whom we otherwise don't know so much about, right? Who was Einstein we knew, but where he was born and how his childhood was like spent. These are some information you might think this probably is not useful, but in the long run you will find that every information is useful in terms of scientific world. So this is, thank you Suhana, and we want to see you again and again, but as Rita ma'am suggested, please practice it more later on so that we can have more interaction. Okay, but come back again, like we will do some more programs when you want, we want to see you again participating. And then fourth of our Vijnanika Shakti children is a little bit older, from class 6 level. She is Ishita Mondal, is in class 7. And Ishita has mentioned that she is having exams, so she could not prepare about Albert Einstein, but which is absolutely fine, Ishita, because it's not only Albert Einstein's birthday which we are trying to like celebrate here, because we want to actually let everyone know about his life and work, but also one great importance is about pi. And what is pi? We all know about pi, and we understand, probably now we'll understand more as we will listen to Dr. Purabi Mukherjee, who is a mathematician. But thanks, Ishita. So please, you can start your presentation, and with that, we will be done with the students' presentation today. And then we will move to our honorary guests who are waiting actually for their talks. So Ishita, you can start.
Okay, ma'am. Ma'am, is the presentation visible? Ma'am, you are muted, so I can't hear you.
Okay, sorry. Yes, it is visible. You have to just do it full screen.
Yes. What is pi? Ma'am, is it visible?
It is visible, Suhana. You can go on.
Okay, ma'am. What is pi? A small presentation by Ishita Munda. Today we are all here to celebrate Pi Day. So first of all, I would like to tell that why is Pi Day celebrated on 14th March only? March 14 is Pi Day because the date 3 by 14 resembles the mathematical constant's approximate value of 3.14. That number, as you no doubt remember from math class way back when, is the ratio of a circle's circumference to its diameter. So first I'm going to give a brief description about pi. The number pi is a mathematical constant. The number pi is a mathematical constant approximately equal to 3.14 or 22 by 7. It appears in many formulas in all areas of mathematics and physics. The earliest known use of the Greek letter pi to represent the ratio of a circle's circumference to its diameter was by the Welsh mathematician William Jones in 1706. It is also referred to as Archimedes' constant. It is an irrational number. Pi cannot be expressed as a common fraction, although fractions such as 22 by 7 are commonly used to approximate it. Now I would like to tell you about the man who invented pi. The history of the constant ratio of the circumference to the diameter of any circle is as old as man's desire to measure. Whereas the symbol for this ratio, known today as pi, dates from the early 18th century. It is widely believed that the great Swiss-born mathematician Leonhard Euler from 1707 to 1783 introduced the symbol pi into common use. Before the appearance of the symbol pi, approximations such as 22 by 7 and 355 by 113 had also been used to express the ratio, which may have given the impression that it was a rational number, though he did not prove it. Jones believed that pi was an irrational number, an infinite, non-repeating sequence of digits that could never totally be expressed in numerical form. In Synopsis, he wrote, the exact proportion between the diameter and the circumference can never be expressed in numbers. Consequently, a symbol was required to represent an ideal that can be approached but never reached. For this, Jones recognized that only a pure Platonic symbol would suffice. What is the significance of pi? It's the ratio of the circumference of a circle to its diameter, a number just a little bit bigger than 3. The constant pi helps us understand our universe with greater clarity. The definition of pi inspired a new notion of the measurement of angles, a new unit of measurement. Thank you, ma'am.
Thank you, Ishita. That was a fresh breath from Albert Einstein's life that we
And
were
very
discussing
matured
till
presentation,
now.
very matured, very
Yes,
nice presentation.
very mature presentation and very well defined presentation. That's because like she's also like in a higher class. That actually is very prevalent from her presentation. Thanks all. And as I have told many times that Ishita is also someone who doesn't really come forward to present because she is very busy with classes and so on. But I'm really happy that you're coming forward within your exam schedule to take part in the program, and that's what we want for all of you. But unfortunately, it's not happening. We have to do something much more innovative, maybe, which we will are in the plan. So thank you. Thanks to all the children who have presented so nicely, so maturely. Those who are new here, I have written that please also practice as you go on. For every presentation, it will be even better. And that's the goal of it. And that you emerge to be a good presenter. Your vocal power increases so that you can come forward with confidence to any place you go. That is also something that we want to inculcate here, not only scientific thinking, but scientific thinking with great confidence. So thank you to all the Vijnanika Shakti children who presented today, and not only that, who encouraged them, who are here. Thank you to all of you. And now we will move forward to our honorary presenters, honorary guests here. First, Dr. Purabi Mukherjee. Ma'am, can you hear us now? Can you please unmute yourself so that we can hear you? Ma'am, you have to unmute yourself. Unmute. Yes, press the... Yes. So can you hear us? Again, your mute button actually is pressed, ma'am. So just press the mute button and it will be unmute. You don't have to double press. Yes, ma'am, but we cannot hear you properly. Rita Deep is still, I guess, like...
দিদি একটু কথা বলুন, একটু কথা বলুন।
একটু কথা বলুন, তাহলে আমি বুঝতে পারবো যে শোনা যাচ্ছে। Should we move ahead with
না 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 না, একটা কাজ করুন দিদি, আপনি কথা বলুন, আর নয়তো ফোনটায় আমায় ফোন করুন, আমি ওটা ইয়ে করে দিচ্ছি, মাইক্রোফোনে দিয়ে দিচ্ছি। দিদি শুনতে পাচ্ছেন?
না, উনি আবার স্ক্রিনটা অফ হয়ে গেছে, মানে ভিডিওটা দেখা যাচ্ছে না। শি ইজ আনমিউট, কিন্তু অন্যকে শোনা যাচ্ছে না।
হ্যালো হ্যালো, হ্যাঁ দিদি আপনি আনমিউট করুন।
That is the reason why we should have, and we have started offline classes, because then there is no issue of mute unmute, right? People who are actually big scientists, they have served for like maybe 20-30 years. They're quite old also. It is very difficult for them to cope up with all these technologies which are coming up. They are not so habituated with this. So before actually, while her mic settles in and so on, so I can go on with introducing Dr. Mukherjee to all of you. When she has a very decorated curriculum vitae, means her CV is very, very powerful. But I will just selectively say a few things so that you can understand that what great work
we can
she has
hear
done.
or not. দিদি এবার কথা বলুন, ওখানে কথা বলুন, আনমিউট করেছেন এবার। হ্যাঁ, I can hear you. Just a minute.
Please, you can hear me on the mic.
Yeah, this way will also work if she mutes herself in the screen, and সেটাই আমি বলছিলাম।
কিন্তু উনি আনমিউট করেছেন, কিন্তু শোনা যাচ্ছে না কেন?
I don't know, might be some mic issue is there. কিন্তু ওনাকে
দিদি
mute
আপনি
করতে
আমার ফোনে কথা বলুন, আর ওটাই দেখুন, আমার ফোনে কথা বলুন, আপনার শোনা যাচ্ছে না কিছু, ঠিক আছে? ওকে, হ্যাঁ বলুন বলুন এবারে। হ্যাঁ হ্যাঁ, পাওয়ার পয়েন্টটা এবার শেয়ার করছি।
হ্যাঁ, আমি শেয়ার করছি, তার আগে ওনাকে I have to introduce her,
শেয়ার করে নাও, উনি সেটা দেখে দেখে বলবে।
শেয়ার করা আছে,
বাস
দেখুন। আচ্ছা, let me introduce her first. Actually, that's what I was doing. Okay, so her presentation is here, which is shared. Can she see the presentation? উনি কি দেখতে পাচ্ছেন? আপনার কথা, আপনি মিউট আছেন, রীতা ম্যাম।
হ্যাঁ, আমি ওনার সাথে কথা বলছি বলে আমি আনমিউট
আচ্ছা।
করলাম। হ্যাঁ,
আচ্ছা।
উনি ল্যাপটপে আছে, আমরা সবাই ওনার প্রেজেন্টেশন দেখতে পাচ্ছি, কিন্তু উনি প্রেজেন্টেশনটাও দেখতে পাচ্ছেন না।
ওকে,
তাহলে
then that's
আপনি
a problem
একবার
actually.
বেরিয়ে আর একবার ঢুকুন, তাছাড়া আর উপায় নেই কিছু।
হ্যাঁ, সেটাই আমি বলছিলাম যে for the people who have been like who are retired and so they are not so used to this kind of
Now I
system.
can, yes. Now I can see.
হ্যাঁ, তাহলে
You can
আপনি
see?
বলুন, আপনাকে হ্যাঁ
বলবো?
নাও, হ্যাঁ হ্যাঁ, just a minute. On Dr. Anuja Datta, who is a scientist working in ISCS, and she is the in charge of this Vijnanika Shakti VIPNET club for girls, and she will introduce Dr. Purobi Mukherjee, and after that Dr. Purobi Mukherjee will speak on International Day of Mathematics PI and a few words about Albert Einstein. Now Anuja, please.
Sure. Sure, thank you. And ma'am, you can see your presentation. I'm sharing your screen. Is it okay?
Yes.
Okay, thank you, ma'am. So let me introduce one of the pioneers in mathematics. We are fortunate to have with us Dr. Ms. Purobi Mukherjee, and she has a very nice profile and very decorated profile, as I was mentioning. That Dr. Mukherjee obtained her PhD degree in applied mathematics. So she is a mathematics person from all through. In 1987, long time when you're not born even, from Jadavpur University in Calcutta. And then she was recipient of 2 National Best Paper Award, which is one of the very few people also get. And from the Indian Society of Earthquake Technology of the Didan Roorkee University, and also on her original work on mathematical modeling in geophysics. And from till 2014, for 20 years, she served in mathematics department of Gokhale Memorial Girls College, Kolkata, which is a very renowned girls college in Calcutta. And she also served as a counselor of mathematics at Indira Gandhi Open University, National Open University, IGNOU, Kolkata Center, for more than 20 years. So she has more than 20 years of teaching experience in mathematics, very high profile. And she taught at the postgraduate class of mathematics department at the Rabindra Bharati University as well for a few years. And after completing her doctorate degree, becoming like doctorate, she continued to work on the mathematical modeling in geophysics, theoretical seismology, which is related to geology actually. And from 2010, then she became interested in the history of science, and then she started research in that discipline. And since 2010, she completed 3 major research projects related to history of science, which are sponsored by National Science Academy, which is a renowned science academy in India. She has published more than 45 research papers in reputed journals, of which 21 scientific articles in Bengali scientific magazines, which is very important because exploring and science in our own language is very much necessary for making it popular and to reach out to the common people. And she is a member of Executive Council of India Institute of Science, Education and Culture. She is also editor of a few journals, Indian Science Cruiser. She is life member of Calcutta Mathematical Society, Indian Society of History of Mathematics, Indian Society of Radiation Physics, Mathematical Consortium, etc. She published 2 books in English on the history of Calcutta, history of the Calcutta School of Physical Science, and also on research schools on number theory of India. Vigyan Shadhak Sri Kariyamanikam Krishnan, and she is also senior author of 2nd Bengali book. She has written several Bengali books for science, And she loves, apart from her very decorated scientific career as a mathematician, as an author, she also loves reading fictions. And this is something that we discussed a few days back, that if you are in science, reading and practicing science fiction is also something that can increase your vocabulary, your writing skills. And she is a perfect example of that. And she has written, she has loved reading fictions and poetry books in English and Bengali. She herself has published a book on Bengali and English poems. She is passionate about Tagore songs, because Tagore is, to be honest, we will probably let her know that Tagore is so much related to scientific activities as well. And Einstein, here one relevant, maybe Einstein and Tagore were very close when they were in the same time. So we saw many pictures where Einstein was so much interested in Tagore's idea of education. And they talked about how to improve education in India together. So thank you. We are so much fortunate to have Dr. Mukherjee here. She will talk to you with so much of experience. She will talk to you about mathematics of Pi Day, about pi, and a few about Albert Einstein as well, because it's also Albert Einstein's birthday. So on this occasion, I will ask Dr. Mukherjee. So please, can you start your presentation? I will scroll down as you will instruct me. This is a rare occasion when we have to coordinate, but I hope it will be fine.
বলুন, এই যে
স্ক্রল করা যাবে তো?
হ্যাঁ হ্যাঁ হ্যাঁ, অনুজা করবে স্ক্রল।
Thank you very much.
আমি স্ক্রল করে দেব।
Elaborate introduction. I don't deserve it. Can you hear me?
Yes, ma'am, we can hear you.
Okay. I think this. Can I scroll this?
Now next slide, please.
Okay, sorry.
Next slide, please.
This is the first question.
This is the first slide. Yeah. I think the students have spoken a lot about pi and also about Einstein. It was quite impressive. They know a lot. So I need not repeat. They have already said why 14 March is called the Pi Day, because the approximate value of pi, since pi is an irrational number, it can be expressed as a fraction of 22 by 7. And the approximate value. Next slide, please.
Anuja, next slide.
Next slide,
Okay.
please.
Sorry, it's not very clear. I could not follow.
Next slide, please.
Yes.
Next.
Yeah. As you see, the approximate value of pi. No, don't skip the previous one.
Okay.
The previous one.
This one.
But
Yes. This one. Yes. As you see, the approximate value of pi is 3.14159, etc. So the 3 before decimal is represented as the third month of the year, that is March, and 14 after the decimal is used for the date. That is why 14 March has been named as Pi Day. Incidentally, as you have already said, one of the greatest scientists of modern times, Albert Einstein, was born on this date. Another great physicist, John Hawkins, passed away on this date. Next slide, please. But first, let us discuss why a mathematical symbol is treated with such importance, or perhaps why mathematics is so important. I presume it is obvious to all that every aspect of our daily life and existence needs mathematics all the time. From the ancient times, man started counting, saving, dividing, bartering. Every activity needed arithmetic, an important branch of mathematics. In modern times, from computers to rockets, from missiles to cryptography, everything needs mathematics. I suppose you know what is cryptography. Cryptography is the science of decoding coded messages. And there, without number theory, it cannot be done. So it is completely dependent on mathematics. Next slide, please. From a grocer, a vendor of vegetables, shopkeeper, bank, post offices, malls, credit and debit cards, computers, smartphones, etc. Everything is mathematics for operational, structural, and day-to-day use. In short, our very existence is dependent on mathematics, starting from the four basic operations, the highest level of branches of this discipline, such as number theory, probability, dynamics, hydrostatics, and fluid mechanics, and so on. Next slide, please. Scientists through the ages have noticed, often with some astonishment, not only the remarkable success of mathematics in describing the natural world, but also the fact that the best mathematical formulations are usually those that are most beautiful. In this context, some quotations from famous personalities may be worthy of attention. Famous British mathematician J.H. Hardy, who was incidentally the mentor and guide of Srinivasa Ramanujan. It was Hardy who had discovered Ramanujan, who was in Madras working as a clerk in an office, and Hardy arranged for him to go to Cambridge, and that's how the Western world came to know Ramanujan. So Hardy is very famous that way. Next slide, please. Next slide, please. In his book, A Mathematician's Apology, Hardy wrote, quote, "Beauty is the first test. There is no permanent place in the world for ugly mathematics." Unquote. Mathematician turned philosopher Bertrand Russell, 1972, there's a typo. He was actually, he died in 1972. Commented, mathematics rightly viewed possesses not only truth, but supreme beauty, the bold and austere beauty, like that of a sculpture, without appeal to any part of our weaker nature, without the gorgeous trappings of painting or music, yet sublimely pure and capable of a stern perfection, such as only greatest art can show. Next slide, please. Henri Poincaré, a noted and widely admired French polymath, wrote in his essay titled Mathematical Creation that ignoring subjective experience would be to forget the feeling of mathematical beauty, the harmony of numbers and forms, of geometric elegance, etc. Another gem of a comment came from our own Gurudev, Professor Shakti, who stated, "The enchantment of rhythm is obviously felt in music. The rhythm is inherent, the notes and their grouping. It is the magic of mathematics, rhythm which is at the heart of all creation, which moves the atom and its different measures, fashions gold and lead, the rose and the thorn, the sun and the planet, the variety and the vicissitudes of man's history. These are the dark steps of numbers in the arena of time and space, which weave the Maya of appearance. We believe any fact is true because of a harmony, a rhythm and reason, the process of which is analyzable by the logic of mathematics. Next slide, please. Now let us first see how does one define pi. As the students have already said, it is defined as the ratio of a circle's circumference to its diameter. In 1988, this day was recognized by Physicist Larry Shaw, and he organized a huge celebration in San Francisco, USA. Later, in 2019, the UNESCO is United Nations Educational, Scientific, Cultural Organization. UNESCO's 40th General Conference, this day, 14 March every year, was declared as the International Year of Mathematics. Now we go back to the historic significance of pi. This Greek symbol has been in vogue since the time of probably Archimedes. But the number pi has been in use since ancient times in all the ancient civilizations. Indian references are the oldest. It is regularly mentioned in Bodhayana Sutras around 800 BC, Apastamba Sutras around 600 BC, and Brahmana Sutras. The value of pi emerged when squares were transformed into circles of equal area. This was necessary during construction of altars of certain shapes and sizes for performing religious rituals. Egyptians and Babylonians required fairly accurate approximations of pi for practical computation. Around 250 BC, the Greek mathematical scientist Archimedes first introduced the symbol pi following an alphabet for the Greek language. He also created an algorithm to approximate pi with arbitrary accuracy. In the 5th century AD, the Chinese mathematicians approximated pi to 7 digits. Next slide, please. Around the same time, the ancient Indian mathematicians approximated the value of pi to 5 digits. Both the Chinese and the Indian mathematicians used geometrical techniques for calculation. The first computational formula for pi, based on an infinite series, now known world over as the Madhava-Lightning series, was discovered by the mathematicians of the Kerala School of Astronomy and Mathematics. The methods used are clearly documented in the treatise Shakti written around 1530 AD. Next slide. Ramanujan's 1914 publication on modularization and approximations to pi is the algorithms for evaluation of pi that are fastest in use today. Very recently, Ramanujan's transformations for elliptic functions were used by David and Gregory Tudovsky to produce very rapidly converted algorithms to compute pi. They have now computed pi to the order of a billion digits. Next slide, please. Now, a few well-known facts about pi are being mentioned. Pi is an irrational number. That means it is a non-terminating, non-recurring decimal. Its decimal digits appear to be randomly distributed, and there is a conjecture which states that it satisfies a specific kind of statistical randomness. But the conjecture is yet to be proved, so this is an open problem. Anyone can tackle it and will see it being settled. Next, pi is a transcendental number. It is not the root of any polynomial with rational coefficient. Pi being an irrational number can be expressed as a common fraction, and it is approximately written as 22 by 7. Next slide. I think Albert Einstein students have already spoken in details about him. I just mentioned that from Germany, In 1895, he moved over to Zurich in Switzerland for further studies, and he also gave up his German citizenship. In 1900, he graduated in mathematics and physics from Zurich University. In 1901, he acquired his citizenship in Switzerland. In 1905, he was awarded the PhD degree from the University of Zurich. Next slide, please. 1905 is referred to as annus mirabilis. That year, he published 4 groundbreaking research papers. In these papers, he outlined the theory of photoelectric effects, explained Brownian motion, introduced special relativity, and derived the world-famous mass-related equation, which students have already mentioned, E is equal to mc squared. In 1916, he published a paper and introduced the idea of general relativity. Next slide, please. Einstein believed that the laws of classical mechanics would not be reconciled with those governing the electromagnetic field. This led to the development of the special theory of relativity. It then extended the theory to the gravitational field. His famous equation E is equal to mc squared, where E is equal to energy generated, N is equal to mass, and C is equal to velocity of light, is the backbone of nuclear physics. Because as in C, however small m may be, since C is the velocity of light, so C squared would be an astronomical figure. That is why the energy generated would be enormous. In 1917, Dr. Albert Einstein was made the director of Kaiser Wilhelm Institute of Physics in erstwhile Prussia. Around the same time, he took up the citizenship of Prussia. In 1921, Professor Albert Einstein was awarded the Nobel Prize for Physics in recognition of his discovery of the law of photoelectric effects. This was a pivotal step in the development of quantum theory of physics. Next slide. Essentially, Einstein was a theoretical physicist. He is widely acknowledged as one of the greatest physicists of all time. He is best known for the development of the theory of relativity. He also made important contributions to the development of the theory of quantum mechanics. Quantum mechanics and relativity are together the two giant pillars of modern physics. In 1933, while Albert Einstein was visiting USA, Adolf Hitler came to power in Germany. Einstein, who was of Jewish origin, objected to the policies of the newly elected Nazi government, so he decided to permanently settle down in USA. In 1940, he was formally given the citizenship of USA. From 1933, he worked at the newly established Institute for Advanced Study at Princeton University, USA. Einstein passed away in 1965. So, that's all I have to say. Thanks very much for giving me the opportunity of interacting with the students. If you have any questions, my dear students, I am at your service.
Thank you.
If you have any question, it was a nice enlightening talk on pi mathematical symbol and from a mathematician's mouth, and on Albert Einstein's unique life that we all are by now we are aware of. So any question, if you want to interact with Dr. Mukherjee, you're free to do that. I think it's a little bit like their age wise, a little bit of higher understanding for pi. That's why they are not vocal too much on Pi Day.
Thank you.
But,
it was a pleasure. Thanks.
But
Thank you.
thank you, Dr. Mukherjee. Thank you. Thanks a lot. And in spite of all the technical problem, that you did stick to like giving such a nice presentation. It was, we are fortunate to
Now
have
please
you
call
with
next
us.
speaker because students, they have school and classes.
Yes, of course. So we are again running out of time because this is a school day. So I would like to request Dr. Jajati Nayak, who is our next speaker. So you are here?
Yes,
Yeah.
yes.
Yes, sir.
Okay, yeah, sorry. Yeah, I saw you probably there. And Dr. Nayak is quite well-known scientist in theoretical physics department in Variable Energy Cyclotron Center, Kolkata. He is a scientific officer there right now, and he did his PhD from Homi Bhabha National Institute, also BCC in India. And before that obtained his master's degree and bachelor's degree from Utkal University, which is the Ravenshaw College, actually, which is a very famous college. And his research interest, like what he is working on as a physicist, is mainly on the hydrodynamics, heavy ion collision. These are probably not a very easy subject to understand, as we will know from, because you are all children here. But Dr. Nayak has promised that he will try to make as lucid as possible in his presentation and his explanation. So we are very eager to listen to Dr. Nayak on this day of Pi Day, and also on Albert Einstein birthday, because he is the father of modern physics, and that is the reason why we are here gathered. Thank you. So, Dr. Nayak, if do you have any presentation you can share? And
Yeah, thank you much for the introduction. I can also speak, or I can send the presentation, because here in office, basically Zoom is not allowed through the desktop, so I have joined through my mobile.
Yes.
So I am sending. If you can give your email ID, then I can send the PPT. You can share.
This is Vijnanika Shakti. I can actually write down here. So what you do, you can send the presentation and I can download it. Yes, these are the limitations of actually national labs sometimes. This is a Science Club Gmail ID. You can send your presentation right now and I will download it. I can share it with you.
Just one vanished. 1 minute. Start probably.
So this is something actually for the children, and maybe a new information, that if you're working in a laboratory such as like in the modern physics labs, you have sent it. Okay, thank you. Let me see. Then actually sometimes you are not allowed to use your phone for a long time also. Like let's say in Bhabha Atomic Energy Research, BARC, where so many scientists are working, they are not allowed to even like check their mobiles during the working time. So they have to keep their mobile outside their place, and they're not allowed to access their mobile when they're working. This is the something that you have to actually maintain. So brief introductions to, just a minute, give me some time somehow. Select. Okay, so is it visible? So
yeah, you can go to the full screen, or you can press F5.
yes, let me try, and tell you somehow my screen here is not working properly. So I'm presenting F5, but anyways, it's not. So I'm just zooming it. If it's possible for you to see.
Yeah, this is fine. Yeah, probably this is fine.
Okay, then I'll scroll down. while you are saying.
Okay, that is fine, no problem. Now, scroll down would be, this is a different kind of PDF. If you scroll down, then same thing would appear again and again, because this map slide is made through LaTeX.
Oh,
So,
okay. Just a
maybe,
minute. Then let me open the slide and sure somehow like I opened it, but
simply you double click it, and then that would be fine also. If you simply double click, that would be fine.
I did.
You can open through any PDF, anything, but
just a minute. Right now, I'm actually have not selected it, but this is what is happening. Can you see now?
Yeah. This is perfectly fine. Perfectly fine.
Yeah, and then I'll scroll down to the slides so that you can go to the slides.
Not scroll down. You can go to, use the right arrow. That will be better.
Right arrow. Yes, I can. So now the second slide is on, right? With you.
Yes.
You can see. Yes. So that way I will go. Thank you, sir.
Okay. So probably the students are class 6, 7 like that. Right? Okay. So I thought maybe 10th, 12 students. So fine. So I would just tell like a story. As we know, so today is the International Mathematics Day. Like we observe the National Mathematics Day on 22nd December to commemorate Srinivasa Ramanujan's birthday. So similarly, this is another commemoration. So that is International Mathematics Day, and we also call as Pi Day. So Pi Day already, Madam Professor Purvi Mukherjee has explained why it is called Pi Day, because today is 14th March or March 14. March is basically represents the third of the month. This is 12 months, so that is 3, and 14 is like 1/4. So we know pi has a value 3.14, and then it continues. It's basically irrational number. So if we generally we use 3.14 as the value of pi in our most of our calculations. So 3.14. That's why this is called Pi Day. And why pi? That is because we know. So this particular constant plays a significant role in mathematics, hence in physics. So, and coincidentally, this is the birthday of Albert Einstein, March 14, 1879. He was basically 10 years junior to Mahatma Gandhi. So Mahatma Gandhi was 1869. So Albert Einstein was 10 years junior to Mahatma Gandhi. And then you see the coincidence, like International Mathematics Day. Also, this is the birthday of another great physicist, Albert Einstein, whom we call as basically the physicist of all time, or greatest physicist of all time. And also the departure of another mathematician and physicist, Stephen Hawking. We know he was a very popular physicist, theoretical physicist and mathematician in the century, Stephen Hawking. So this coincidence, we can just make an analogy. So such a coincidence of two great physicists and mathematician, and also Pi Day. This tells that really mathematics and physics have some inseparable bond. So physics, we know what is physics. Basically, it basically explains the natural phenomena, explains the natural events, and mathematics is the language of that expression. So how one explains, we know we explain through equations, we explain through mathematical expressions. So that is mathematics is the language of the science that we call. So mathematics and physics basically have some inseparable bond while we talk natural phenomena. And let me discuss the part that is given to me, basically Einstein's contribution to the field of science. Why we say Einstein is a genius, or to what extent he contributed to the field of science. Basically, Einstein's have four major contributions to the field of science. He had many contributions, but 4 major contributions, if we can categorize, then one contribution is called Brownian motion. I would explain what is Brownian motion. And the second one is called the photoelectric effect. And third one is called special theory of relativity. I would say what is relativity. And the fourth one is the general theory of relativity. But in between, he had also another pioneering paper, pioneering basically publication. So which we know that E equal to mc square, and E equal to mc square is basically we know this is a equation which gives us the technology to produce energy. Like we know nuclear reactor, there are nuclear reactors in India, in the world, many places we have nuclear reactors where we produce electrical energy from the atoms, basically nuclei and atoms. So that we use this principle E equal to mc square, this formula E equal to mc square. So which is basically is a result of special theory of relativity. And final one is the general theory of relativity. I would say actually what are these things, how important these four contributions to our life also in some extent our day-to-day life. So Brownian motion, this is obviously you know Albert Einstein. He died in April 18, 1955. So he has written in the blackboard, you see, I love pi. So Brownian motion, the first major contribution by Einstein. So Brownian motion, sometimes if you see, so when there is a dirty water, in the dirty water you see sometimes small particles, they have some kind of random motion, zigzag motion in the liquid. So that's what you can see while going to school. If you have nearby some ponds or small watery body, then you can observe that some tiny particles, those who are suspended in the liquid, they have some kind of zigzag motion. That zigzag motion is called Brownian motion. So basically, the kind of fluid, the particles we consider in the fluid. So in this context, basically, we know those fluid are basically static fluid, stationary fluid. Those fluid do not have a preferential direction of flow. So overall, later on, when you will go to higher class, you know what is momentum, linear momentum, angular momentum, etc. So I thought you are 10th, 12th students, so that's why I wrote in that language. The overall momentum is basically zero. Momentum means this is something motion contained in your body, that is called momentum. So overall momentum of those particles are zero, but they have some zigzag motion. So this motion actually was observed by a botanist, name is Robert Brown. You must have read in your class 6 or 7 Robert Brown. So he observed this phenomenon in 1827. So how did he observe? When he studied, basically observing some pollen of a plant. So those pollen of a plant, he basically immersed in a water, and then he was observing that water through microscope. Then he observed that Brownian kind of motion of these pollen grains. So this such motion was called as Brownian motion after his name. But people could not understand why those pollens make such kind of motions. The people could not, until 100 and next 80, 90 years, people could not explain. And Einstein, most probably after 80 years, Einstein reasoned out or found why these tiny and visible particles were, those were suspended in a liquid, those were making some zigzag motions. Basically, the invisible atoms in the liquid would bombard the suspended particles, which causes the zigzag motion. And Einstein gave this theory in 1905. Basically, so Robert Brown observed 1827. Einstein gave the theory 1905, almost all 80 years, around after 80 years. So then he gave some model, and that is one of the major scientific contributions. Why it is major scientific contribution? Because this has many more applications nowadays. So let me skip details of this Brownian motion. But one important thing of the Brownian motion is that at that time when Einstein explained, by that time atom is something which were although predicted or given, so those are established, but some physicists, they were very much reluctant to accept what is an atom. They were not accepting the concept of atom. But the Brownian motion, when Einstein gave the explanation of the Brownian motion for those pollen grains. So that basically led the reluctant physicist. You can go to the next page. Reluctant physicist to accept the existence of Brownian motion. So that's why next page you can go. This is the basically picture of a Brownian motion. Also, this is some kind of zigzag motion. So this kind of zigzag motion, Einstein first gave the explanation for this kind of zigzag motion. This was his first pioneering contribution in 1905. So then another Einstein is famous for another thing that is called special relativity, special theory of relativity. What is special theory of relativity? What is relativity? Relativity means, so when you move inside the while you are moving from one, let us say you are moving from Howrah to Bhubaneswar by train, sometimes you feel that the trees around the railway track, they are moving, but you are stationary when the train moves. So although you are moving, the trees were stationary, but you feel that those are at rest. You are at rest and they are moving. So that is basically those things one can understand from the relative motion. So from the relative motion between two bodies basically led to the concept of relativity. And relativity, so this is some kind of relative motion between bodies. So that was first given by Galilean much before. And when Einstein came, so he fine-tuned the Galilean relativity, theory of relativity, and add something. So he told that, so this relativity, along with this Galilean relativity, he added that velocity of light. We know light, when we see sunlight, we know sunlight that comes from the sun to the earth, it takes around 5 minutes, 5 to 8 minutes. So we know those light particles, which we call photons, they move with velocity, they move with a constant velocity. What is that constant velocity? That's basically constant velocity in vacuum. So what is that constant velocity? 3 into 10 to the 8 meter per second or 10 to the 5 kilometer per second. That means 1 second, the light travels 3 into 10 to the 5 kilometer or 3 lakh kilometer. And Einstein told that this velocity is constant in vacuum. So then, along with the Galilean relativity, he added this one and he developed a new relativity and relativity theory that is called special relativity. And using this special relativity, we can move on to the next slides. So basically, special relativity. So one can explain the heliocentric model of our solar system. We know Earth is moving around the sun, and we presume the sun is stationary, although the sun is not also at rest. But still then, for our frame of reference, considering our frame of reference, we consider sun is rest, and all the planets are revolving around the sun. This is called heliocentric theory. Helios means sun. So around the sun, planets are moving. So this is basically proved from the special theory of relativity, which is given by Einstein. Well, this is Einstein's second important basically contribution. And we can move on to the next slide. And third important contribution is called photoelectric effect. So photoelectric effect is, what is photoelectric effect? If you take any metal and expose it to, let us say, sunlight, so then what happens? The emission of electrons from that metal, right? So when this light or the radiation falls on the metal surfaces, so that those electrons which come out of the metal surface, those are called photoelectrons, and the process is called photoelectric effect. And this has huge applications in the day-to-day life. So like Xerox machine, printing, imaging, solar cells, and optic fiber telecommunications. You are basically now much more acquainted with these mobile phones, etc. So the huge application of photoelectric effect. So this is another third major contribution by Einstein to the field of science. And Then fourth contribution, major contribution, is called general theory of relativity. So this is some theory which you cannot understand at this age, but you just remember this is another special contribution, important contribution, which tells how the gravitational force means when the apple falls from the tree, so it has a downward motion. So when any massive object which has mass that falls to the earth, why it falls to the earth? That is because of the gravity. So this gravity is a very complicated phenomena. So that gravity is explained by Albert Einstein through the general theory of relativity, and that is the latest contribution of the Einstein. And people call, so this the general theory of relativity is the most important contribution till now we had or any other physicist gave to this scientific community or to the world. So this general theory is a really highly conceptual thing. So but unfortunately Einstein at that time, when got the Nobel Prize, he could not get the credit for this general theory of relativity. Much later people understood. And let me tell you, so the next slides we can go. The general theory of relativity is basically what is the typical example application. So application is GPS. So when you have mobile, you move from one place to another. Let us say you unknown place you want to move. So then you switch on your GPS and then basically write down the name of the place, and automatically you get the track, basically how to move. So this is called global positioning system, and that within a fraction of second, the path you are getting is because of the help of many satellites that is basically orbiting around the Earth. So this global positioning system or GPS is a classic example of application of general theory of relativity. And the global positioning GPS is a space-based radio navigation system consisting of a constellation of satellites. Many satellites are there around the Earth. So currently GPS satellite, and that the satellites that orbit Earth at an altitude of a height of 11,000 miles from the Earth, and they give accurate information on the position, velocity at any time in the world in all weather conditions. But one important incredible thing that I want to mention, that's right now India has its own satellite, the Indian Regional Navigation Satellite Systems, that is called NAVIC. So that was launched in April 2019 when the pandemic was there. Sorry, not pandemic, just before the pandemic. So India launched this NAVIC GPS system. Now mostly there are devices available in the NAVIC system. So this GPS system can they basically are used in many things, like disaster management, when the cyclone will come, how this cyclone moves, to what direction, etc. So precise timing mapping, terrestrial navigations, and somewhere somebody is lost. Let us say somebody is moving to the glacier, he lost. Then using this GPS system one can find out. So these are the many applications. So this general theory of relativity is the fourth contribution, highest contribution by, latest contribution by Einstein. Einstein had many contributions. These contributions are basically, we can say, this profound some impact on the human life. So then let me skip this slide and go to some sort of final slide. Okay. You can skip 2 slides. Yeah. So this slide is fine. Nobel Prize slide. Yeah. So Einstein got Nobel Prize in 1921 because of this theory on photoelectric effect. Because photoelectric effect, which gives some kind of explanation to the quantum science. So when we say Einstein has some contribution to quantum science, when Einstein himself didn't believe at that time quantum mechanics, he was not believing, because quantum mechanics and classical mechanics had some 2 different conceptual base. So but his theory on photoelectric helped develop help understand the quantum mechanics. So he got the Nobel Prize in 1921. And but we know Einstein's most famous equation is energy mass equivalence relation, E equal to mc square. And sometimes it is felt Einstein should have got minimum 3 Nobel Prizes for his 3 famous discoveries. So one discovery is basically Brownian motion, second one is photoelectric effect, third one is special relativity. But obviously for the general relativity, at least when he was awarded with Nobel Prize, by that time 3 of these discoveries were there. So there are 3 discoveries, but 4 papers he published in the scientific journal. So one paper on E equal to mc square, which is a consequence of special relativity. So these 4 papers he published in a single year, that is 1905, and that year is called Annus Mirabilis. So 1905 is called Annus Mirabilis. That means some kind of mirabilis, some kind of marvelous, wonderful thing people call in Latin. So that is mirabilis. So annus is basically annum from the year. So the year of wonderful, you can say wonderful year in the scientific calendar. So that is called the basic annus mirabilis 1905. So but after that he developed this general theory of relativity. So this is basically major contributions. If we categorize major contributions of Einstein in 4 things, so the 4 things is basically Brownian motion, photoelectric effect, special relativity, and E equal to mc square. And then general relativity, E equal to mc square is a consequence of special relativity. So that's all. So thank you very much. If you have.
Thank you, Dr. Nayak. And the children, definitely they are small, but I think like it was a very engrossing talk, and I really enjoyed every bit of it. As with the filled up of information, not only that, you explained it very nicely. And now, like students, children, do you want to interact? I mean, if you have any question, feel free to ask, sir. He's a pioneer in this field. So I would like you to interact with him as much as possible. So any question do you have from your side? Anything that you want to ask about maybe theory of relativity, speed of light, or anything that you've understood from there? Yeah, I think they are all like, well, something like they understood a few of the things, and they are also like they have exams. So they are still kind of studying their things, and they want to kind of join their school studies after this thing. But thank you, Dr. Nayak. And one thing actually is something that I probably might be, I don't know whether children are allowed to visit VECC, but if they are, sometimes they're allowed. Sometimes in like near future, actually, that I would really like to do. I mean, I would like these children. There are only a few children here today. That's because like we have almost 50 of the children with us. I mean, who are actively participating all the times. And apart from that, we have, if we accumulate, we have more than that, of course, 80 to 100. But I'm not talking about we are arranging it for 100 students, but maybe selected maybe 20, 25 students, actually children of varying age, if they can visit.
Up to 50, there is no problem. So we have a public awareness committee, they take care. So even if they arrange here some quiz, some kind of, so they distribute some kind of caps, etc. So they encourage also here. So we have a system existing to this kind of activity for the public awareness.
That is very good. Actually, that's what we want. Actually, they are of varying age, starting from class 3, 4 to class 7, 8. That's the pool what they have. We have. Class, what happens like class 9 to 11, 12, they're very busy in their board exam studies and all these things. So we do not get much activities from there every day, but whenever, if you're arranging something like this, they might be very interested also to go and explore what variable VECC is doing. So that is something maybe we, if you kind of think it will be possible for us to kind of.
Basically in our website also there is a form available, so that form can be filled up and sent, and then we have a PAC committee that sits and decides how to make smaller groups and take to different places, different lab, basically labs, and then they would help. We have 3-4 persons, they would guide them and then explain also what is happening.
But for the children of this age, it is okay to go to visit there?
I think 10th, 12th would be better. So 9th, beyond 9th, it would be better. Have a little bit of understanding of electricity, magnetism, that is better.
Right. Okay. Thank you very much. Thank you, Dr. Nayak, and for spending so much time with us. And with these, actually, we are already almost reaching 8 o'clock. And I'd like to end the program here today. And it was wonderful that all of you could join. In spite of your busy schedule, the children also, their parents, they're encouraging them. And we are taking part in this kind of program every day. So next, actually, we want to meet like around, so we are having like a very important birthday coming up. And that is Kalpana Chawla's birthday, which is actually on 17th. So we are not going to actually meet on 17th, but what I want to, and this is like then our holy vacation is starting. So something what students are also requesting that maybe we can do a movie night and movie evening, that we normally encourage them to see the scientific movies and documentaries as well. So Sunday, that's a plan that maybe we can arrange for a movie or the documentary evening for all of you. So we will see possibly together if you can assemble on Sunday 20th for a movie evening. Okay. And in March, we have another important event, but we are in the plan for that, as we also said that all the children who have participated in all the competitions and everything, we want to meet with them and all the Vijnanika Shakti children again in person. So maybe end of March, we are going to organize an offline meet, and that's in the plan, but I will announce it very shortly. Okay. Thank you, and thanks for being here. So Rita ma'am, over to you if you want to conclude with a few words. You're muted.
Mayuri is there? No.
Oh, the Mayuri Di actually left. Otherwise, I would have actually called her. Yes. I saw her, but then in the meantime, she left. Oh. Yes.
So anyway, thanks to our two.
We have actually another mathematician here today. It's a mathematician, but mathematics teacher along with us, Shomare.
She should say something, few words.
She should say also something.
First, requesting.
Shoma, you are here.
Yes, Shoma is very much here.
Yeah, and Shoma ma'am also shared a very nice video actually along with you. So Shoma ma'am, if you, she is a mathematics teacher in St. Xavier's Collegiate School, right?
Thank you. Dr. Jajati Keshari Nayak, thank you so much. You have come and you are with us and you blessed our children. It is really, really a very, very good and very encouragement for all of the students. Thank you so much. In spite of your busy schedule, you have come to us. Thank you so much.
Thank you, ma'am. Thank you.
Thank you. And now, Somare, you please say some words because you are a mathematics teacher.
Actually, everything ma'am has told, and you know, and my dear little children, so you are becoming day by day the researchers. So you have found all the things. So a little bit thing I want to share the thing. Already I have shared the presentation in the group also. If you want to know about the pi, so already you know that is the 14th March and why it is coming. So you have the idea about the thing. Those who know about the circle, so the circumference of the circle, you know that is the 2 pi r, and the diameter of the circle, that is the 2 times of the radius, that is the 2r. When in each case, so you are going to just make the ratio 2 pi r by the 2r. So you are going to get the constant pi. And in each case, so that means whenever you are going to change the radius and everything, so that is the constant term. And it is coming from the, if you go through, may I share the screen?
Sure.
Sure.
Okay, so just
What happened to you, Shoma?
Yeah, is it visible?
No, no.
No, no, actually.
No,
So what
ma'am.
we can do, it is not visible.
It is not
You have
visible.
already shared it in the group, right?
Yeah.
Yeah, so
So
it's
can
not
you
visible.
May I leave because I
Let's make which group we have shared. Actually, there are so many groups, but
Ma'am, may I leave?
Yes,
Ma'am, because I have other class.
I know you have to leave. I have to leave. Shoma,
Yeah, yeah.
2 minutes. What 2 minutes, Atrija? I know. You just no need to share the link and this thing. You just tell. Okay? What
Okay.
you want to say, what they didn't say, if there is any
yes,
new
this is
want
just
to,
like yeah.
because they have class and they have so many things to do. It's almost 8, huh?
Okay. So actually, the thing that is the Greek letter 16th. Am I audible?
Yes, very much.
Yes.
So if you go through the page, so you will be observing that is the 16th letter, Greek letter. And next one, that is, we want to share the thing. First of all, the first calculation of the pi was done by Archimedes. And if you go through, so if you have the idea about the regular polygon, he just described the thing that is the within a circle, one square was there, and outer circle and the inner circle. With that part of the thing, he invented the idea about the pi. And if you go through the ancient time, you will be getting that in the Rig Veda. So some few lines I may say about it. That is the sloka is that Gopi Bhagya Modhu Vrata. I think you are not going to get. So just you will be getting from the screen, you will be getting all the word, according to the Sanskrit letter. There is, you will be getting some numerical data. And from that Rig Veda sloka, you will be getting how nicely the pi value is coming 3.141592653, like that. That is the infinite. And so I want to share the thing that is already ma'am has told. After that, it is the process. William Jones, Euler, they have already shared the views about the pi. And the most important thing is that if we don't know the pi, we cannot calculate the volume of our earth also, which is the spherical in shape. And that is the, some of you know that is the volume of the sphere, 4/3 pi r cube. So using of the pi, you will be using the pi in various calculation. And ma'am has already told that is whenever you will be growing up, so there you will be getting the series of the pi series. So this is the thing, and this is the application of the pi I can say about it. And here is a very beautiful rhyme also you will be going through. And that's all about the thing.
Thank you. Thanks a lot, Shoma. And it was very nice. And actually, you have shared it so the children can go through it and learn that sloka. Yes, learn the sloka. They can recite and relate.
And very nicely, that is, we can inculcate the thing that is the Sanskrit mathematics. They are very much interrelated. Actually, all the Didi can say all the things that is the mathematical terms and mathematical formula we can deduce from the Sanskrit slokas also.
Definitely.
So,
definitely, it's a huge correlation. So thank you.
There is
Rita
one
ma'am,
Autopayadi Sutra.
Yeah.
Autopayadi Sutra, which is very famous sutra in this Sanskrit book in mathematics, ancient Indian mathematics. That can tell very, very easily, very nicely about all this thing. Only the sutras people should understand. Anyway, it's too late. So
Yes,
thank you
we
very
are
much.
almost reaching 8. Thank you.
Thanks to our coordinator. We have to clap for our coordinator, Dr. Anuja Datta, because of her constant and hard work. We are meeting here with all the angels. Thanks to Audrija. She is having class and she is doing very good job today by accepting everyone. So clap for her.
And recording maybe. I mean, she's recording, I don't know.
And also the recording. And here I can see the Dibyangshi and Shubhasri. Thank you so much for being till last. And our very, very dear, this Arya, he is coming and going, I know. But even then, last but not the least, I thank all the members who was presented and all the guests, especially Purobi Madam and Jajati Keshari Nayak. So hope you loved this program and hope you all will tell your friends to join this Vijnanika Shakti VIPNET Science Club. And this club is for you. After some days, we will go for live experiment and we will do one summer camp that will be live and physical. We will make one place for your hand-on experiment, and yearly I'm telling to all the public and to you all, and tell your parents and your teachers, whosoever is interested can join our summer camp. Our summer camp will be in your vacation, summer vacation, and we will have one winter outing camp. So these two camps we will do every year. And whenever is needed, we will meet personally, physically. But before that, even the corona is there and you all kids are really very small. We have to take care of you. That is why it is very difficult to do regular activities regularly. But definitely we are waiting for the summer camp. Thank you very much. Join us. And I'm telling all the students from 7 years to 17 years, girls, please come and be with our angels and make yourself one of the angels. Thank you. Thank you. Bye-bye. Have a very, very, very upcoming days and with scientific mind and with your new research work. Bye.
Bye, bye, ma'am.